tried this yesterday and had technical difficulties. So I've made a bit of progress on my PASS F5 V2 amplifier. You can see its parts are mounted. Before I start, I want to thank all my new subscribers. I never thought I'd actually get 50 subscribers, and I'm real grateful for y'all. I'm shocked anyone would want to listen to me, but thanks for being there, and hopefully I can continue to provide some semi-amusing content for you. So I decided to break the F5 into bits and various pieces. And so what you see is this is the base plate. There's also a bottom cover that goes under this. And then this is the front panel. The capacitor boards will mount on that from the standoffs there. You can see the back panel here. I've got the switch more or less wired up and the speaker terminals wired. I've yet to hunt down where I put my coax cable. So I want to use shielded coax on the RCA ends going to the amplifier boards, since they'll be running by these bad boys. But anyway, I've got a 20 screw terminal strip, 10 position, and it was barely enough, as you can see here. But we've got the hot wire coming in, neutral wire. This one is the ground wire. All these will plug into the switch over here on the back panel. And then what I've done is since the Antec power transformers here have dual primaries, so you can put them in series for 240 volt and parallel for 120 volt. So I decided to just do the parallel, the run separately, and then use jumpers. So you can see the neutral white wires heading out here. The hot wires are basically being routed through these thermistors. They're CL60 thermistors. I think they're rated 5 amp and I forget how many hundred volts. I think 300, not sure. But anyway, they're to slow the inrush current as you turn the amplifier on, which is why I have 4 of them here. Mr. Pass's schematic, if I can dig it out of the wreckage here, shows, here we go. Hopefully we can see that, but you can see he's using just a single one for both hots. Both primaries. I decided to use one for each primary for each transformer, which is why there are 4. And I'm hoping that will, one, ease the burden on the thermistors, but also hopefully give me a slow enough inrush current that this thing doesn't just flip the breaker the minute I turn it on. We'll see. You never know. Anyway, you can see the hot wires go in red, the neutral wires go in black on the transformers. And you can see I also have these green wires going to the star ground here on the chassis. And so now I'm going to set this down again, flip the chassis around. Okay, so you can see we've got this flipped around now, and the ground wires are going to these bridge rectifiers. They're 35 amp monolithic bridge rectifiers, and if you look again, referring back to Mr. Pass's schematic, you can see what he's using these for. Basically, the circuit ground is being floated above the chassis ground by the bridge rectifier. And that gives you roughly 0.6 before it'll actively conduct, I guess. But anyway, there's also a thermistor there to ease, I guess, turn on current. But that's what these guys are. You can see the thermistor sticking up here. And hopefully that works. I had a fellow, when I mentioned it in a online forum, he said, yes, it does wonders for eliminating ground loops, which is good because I usually end up just having to use a lot of cheater plugs. So you can see here the secondary wires. These the Antec transformers have dual secondaries as well. And so that's working well because I basically have a wire for each section of the bridge rectifiers here. These are dual rectifiers or TO220 format. I believe they're the MUR 3020s. I forget. I have to look at the parts list here. This is the schematic for these rectifier boards, and you can see they're dual ones in parallel times 4 to make the actual bridge. So it's a lot of dissipation there. And since I'm splitting the load of the amplifier between two channels in the dual mono configuration here, you can see that there's a lot of little rectifiers in there to spread the load around. Yeah, so we're going into these, and then we're going to continue on to the front panel and the pair of, see, is that right? No, it goes, yeah, this is how it goes. So this will be how it looks on the unit. The front panel will be here, and then you can see I have these wires going to the capacitor boards, and they're each supply gets 1, 2, 3. No, that's not right. I have to go with this schematic. This is the actual DIY audio boards, and so we've got 4 filter capacitors per rail. So there's 4 on the plus 32 volts, 4 on the minus 32 volts for each channel, and these are 15,000 microfarads, 50 volts, so it's giving us roughly 60,000 a rail, 120 per channel, 240 overall. And you can see between the, you have 2 capacitors and you have dropping resistors, lots of dropping resistors, and then 2 more. So 2 dropping resistors, 2 more than the output sides or outboard. I've done it this way with them standing up, so these the outboard outputs can just go right to the amplifier channels, which will be on each side of the chassis. And those are mounted to the heat sinks, which I'll show you a look at yet. I've been fussing with wire quite a bit, and originally I thought to do all of this with using some very nice Teflon wire I had gotten, but I'm finding that the Teflon wire is very stiff and a pain in the ass to bend, especially when you get into the larger gauge sizes like I want to use. and also it's not fitting well in the boards and so on. So what I've been using is some wires I have, which is this stuff is, if you look, it's very flexible. These are test leads for a Fluke brand insulation tester, and it's great. I get this from work, and it's very flexible wire. And if you look, I don't know if you can see that too well, but there's just lots of little tiny strands in there. That's why it's so flexible. So that's made it easy to wire this up. But now that I'm going to the boards, it's going to be a little tighter. So let me pause this and I'll show you what we're talking about. Okay, so we have the amp boards here, and you see they mount to the heat sinks. The heat sinks are effectively the left and right sides of the amplifier, and everything. You have these brackets, top and bottom, on each heat sink. Actually holds the dual heat sinks together. I don't know why that's rocking. It must be sitting on something. But everything bolts to these brackets, front panel, rear panel, and the top and bottom panels as well. Anyway, here's our fussy Teflon wires here. And you can see that I'm having to strip some of the strands away in order to get them to fit in the holes on the boards. This would be my chief complaint with these boards. Well, two complaints. They probably could have used a little more room for the resistors so that I could squeeze in my usual Dale RN, what are these, 55? 65, I think. But the other issue I'm having is these holes. The holes they're using for the wiring are pretty damn tiny. They're not even as big as the ones we have for the output devices, which, had they been, it would have been easier to fit a sizable wire into them, something like this. And instead, I'm having to use this smaller gauge that I've got. And this is Teflon. It's silver wires, copper wires coated with silver and then with Teflon. And they're nice wires, but they're very stiff and difficult to bend. And also the Teflon material is quite soft, which is what makes it a pain in the ass to work with. And if you have normal needle nose where you have the little grooves here for grip, those grooves just tear, equivalent grooves in the Teflon. And I found I could easily, just in the process of bending it, cut down to a wire, which pretty much negated the insulation. So what I've been doing is just, with all this mess you see here, is just trying to get the wire bent by hand. I'm going to try maybe using chopsticks or something. It's just a form to bend the wire around. But I'm in a gradual process of, I started with everything kind of high and loose, and I'm going to be cutting the wires progressively shorter and tightening them up until I get the right profile I want. I don't want the wires sailing sky high over the boards. But it's a little difficult here because the yellow wires you see here are the actual drive circuit for the gates of the MOSFETs coming from the input board here to the output device boards. And sadly, they're right next to the output of the MOSFETs going back to this common area where we'll actually run the speaker, the wire from to the speaker terminals, pardon me. So I'm doing a lot of head scratching, figuring out what's going to be the most tidy arrangement without having wires going willy-nilly, or hopefully not having uh, drive or input wires crossing output wires and so on. Now it's a little more easy on the bottom side here when you have the power supply wires and the ground wires. Those I'm not too concerned about. It may be good for them to be bundled together like that. We'll have to see. But that's about where I am right now. Once I get the unit wired together, or these wired together, I'm going to wire up the front panel over there. Pardon me. And to the base plate and actually do a powering up test to make sure the supplies are behaving themselves, that they're symmetrical, plus and minus 32 volts on both channels. And we'll see how that goes. Now this is my first power amplifier build. I've modified existing amplifiers, but this is the first time I've built one up from scratch. And so I'm a little cautious about doing this. And so I plan to build what's called a dim bulb tester to limit current, but I'm also going to be using a variac. And, oh God, this is one they gave me at work because they tend to do that. If something's not needed in the department anymore, it's, you want this? If I don't take it, it's going in the dumpster. So this one's a little odd in that I think they say it has a 230 volt output. Now I don't know whether it's wired. It has a standard 120 volt cord, so I don't know whether it's stepping up to 230 volts or whether it's just they're hooking it up to some kind of step-up transformer as well. So I'll be doing some testing on this. But this device is a variac. It's a variable transformer, and you can see it goes 0 to 100%, and you just turn the voltage up. And as it comes up, you watch your dim bulb tester to make sure the light bulb doesn't light up to full brightness. If it does, that means the amplifier is drawing current for some reason. Usually not a happy one. So if you haven't seen the inside of a variac before, my friend Charlie gave me this one, which is, bless its heart, it's seen a lot of years. And it concerns me a little just because it has no enclosure, but it does allow you to see how they work. You can see it's a transformer, or probably a big autoformer, on the hot wire, the hot side of the AC wiring. And then if you look, we've got this little as you rotate, there's a little wiper that's going along the top of them, and that allows you to select how much of this winding you want to use. So this is probably a little ballsier than that other one, but I do have concerns about safety using it. Anyway, I'm planning, there are two holes here in the front panel, and I'm going to run little status LEDs from the power boards over to it, to those holes, so that you'll see it with two blue LEDs when it powers up in normal operation. And that's about it. And I want to wish everyone a Merry Christmas and thanks for watching. Stay safe out there, guys. It's crazy. Anyway, thanks for watching. Bye.